Okay guys, we are going to tackle some of the review problems today. Particularly, I want to tackle two of them that are hypothesis testing, because people were sending me messages saying they were having trouble figuring out how to do these problems, so I wanted to go a little slower. So we're just going to do one problem both ways for the whole video. Now, on test 4 review, page 3, there's a problem number 12 where you're given your hypotheses and your null and your alternative, and you're just trying to test them. So I want to go over that without a word problem before we move on to how we take a word problem to the beginning. Now, step 1 of your tests, regardless of which way you're doing it, is always going to be write your hypothesis down, your null hypothesis and your alternative. You can see here that the null hypothesis is that p equals 0.4, and the alternative is p is not equal to 0.4, meaning it could be bigger or smaller, which means it is a two-tailed test because it's a not equal to instead of a greater than or less than. Now, the problem tells you your sample, you took a sample of 1,000 people and 420 of them had that characteristic, and you want your level of significance to be 0.01. So let's talk about that 0.01. If it's two-tailed and you only want 0.01 outside, which is 1% outside of your area, then you want 99% inside. Now that 1% on the outside, since it's two-tailed, is going to be split into two pieces, 0.01 divided by 2, which means they're 0.005 on either side. What this means is when you're looking at the z-table to find your critical value, what we'll do later, you need the 0.99 under there, but you also need the 0.005 for a total of 0.995. Now, step 1 is already done for us, but step 2 is to state what alpha is. Alpha is 0.01. That's not bad, it's given to the problem. Now, I think the thing that causes people the most problems is step 3, which is the big equation where we calculate it. Now remember, we're calculating the z-score, so I'm going to call this a mid-step. We'll call this a z-score is what? It's your score minus the average divided by the standard deviation. That's all it is. Now, they all roll this into one thing. We have the average, it's the 0.4, it's our expected value. But what is R score as a percentage? Well, to find R score, which is p hat, we need to take x, our 420, and divide it by n, 1,000, which is 0.42. Now we have R score now and the average. We also need the standard deviation. This was the square root thing, and this is the square root of p times 1 minus p all over n. Everything is under the square root, so in this case, this is the square root of 0.42 times 1 minus 0.42, all divided by our n in this case was 1,000. It was given to us. So what is our standard deviation? If we put this all into the calculator, let's see. Square root of 0.42 times 1 minus 0.42 divided by 1,000. And I'm going to carry this to a lot of decimal places so that it doesn't cause me any rounding issues. This is 0.0156077. This is just to be safe, because normally I would put it all in one step and I don't want it to get messed up. So to find my z-score for this thing, which is all step 3 actually is to find the z-score, I'm going to use this formula up here, my score minus the average over the standard deviation. So my z-score is equal to, my score was 0.42 minus the expected value, 0.4, divided by this 0.0156077. So if you're getting confused at that step 3 a lot, trying to figure out what was happening, all it was doing is calculating the z-score, and it just puts it all into one step. So now I'm going to do my division. when I get that, I get my z-score, rounding to 2 decimal places always, is 1.28. So I got a z-score of 1.28. So that tells me how many standard deviations away from what I expected to be the answer was if that 0.4 at the very beginning was the actual value. Now, step 4 is to compare it to the critical value. Well, what is the critical value? It goes back up to this thing. It's the z-score if I got the 99% in the middle, because I wanted a 0.01 level of confidence. So it's the z-score for z alpha over 2. So z, remember that means z alpha is when what's to the right, so 0.01 to the 2 over 2 to the right is 0.005. If you look in your z table, this shows that you're looking for 0.995. There is a 0.9949 and a 0.9951, so it's halfway between those two. So this ends up being 2.575. Now, if your z-score is less than the critical value, like between the negative and positives of the critical value, because remember it should be on both sides, then you do not reject. If it is, you do reject. So what 1.28 is less than 2.575, which means that we're in the expected range, which means our conclusion needs to be we do not reject the null hypothesis. And we don't have a word conclusion here because we don't have a word problem, but we can say there is not sufficient evidence to conclude that we can reject the null, that we can accept the alternative hypothesis. So one thing to note about your final statement, it's usually about the alternative hypothesis. We either do or do not reject H0, but our conclusion is usually about the alternative hypothesis, even though we do or do not reject H0. And we're not really accepting the alternative hypothesis, but by not rejecting, we don't really have any information about this problem. I'm not so worried about our word conclusion in this problem. Now, the only difference between this and the p-value approach, step 2, all the way down through step 3, or step 2 is all the way down, is the same. Okay, so step 2 and step 3 are the same. So how does this work when we're doing the p-value approach instead? So instead of taking my alpha over 2 and converting it to a z-score, you take your example z-score from step 3, we got a z-score, it's the same one, of 1.28, and instead, you're going to look in your table for 1.28 and look at the probability. What are the chances of it occurring? The area under the curve for 1.28 is the probability for this is 0.1003. How do you get that? It's 1 minus the z-score of 1.28 because we're looking for the area to the right. Now, because this is a two-tailed test, only on two-tailed tests, you have to double it. So that'd be 0.2006. Now that means the chances of this happening were about 20%. And you only want to look for things in the 1%. So 2.2006 is greater than 0.01. So the probability of this occurring was bigger than 1%, which means I still do not reject H0. So the only thing that's different between the p-value approach and the classical is what you're comparing. In the classical approach, you're comparing z-scores. In the p-value approach, you're comparing the chances for things to happen. So that's the only difference there. So I hope this explains what you're doing, and I'll have another video after this for an actual word problem and how we'll do it.